In this video, we'll talk about the details of pspice simulation. We're going to take the unity gain follower circuit as an example. The operational amplifier used to build up the circuit is UA741. Positive and negative 15 volts are used to power up the op-amp. The output pin, pin number 6, is connected to the negative input pin, pin number 2, through a wire. A sine wave, V3, is fed into the circuit as the input signal through the positive input pin, pin number 3. Double-click V3, we might look at all of the attributes of this part. Three parameters need to be set up to fully define a sine wave: the offset, the amplitude, and the signal frequency. For example, if you want to change any of these attributes, click on it, change to the right value, and click Save Attribute, and OK. Hopefully by now you can understand the schematic. Now let's get to the exciting part, the simulation. First, click on the Simulate button. We can see that there's no error message on simulation. However, at the same time, there's no signal showing up on the simulation window. To call the signal out, we need to enable transient analysis. From Setup Analysis, check Transient. Click on Transient. There are a couple of important parameters need to be understood here. One is the final time, and the second is the print step. The final time defines how long the simulation is, and the print step is like the step size for running the simulation. In this example, a sine wave with a frequency of 100 Hz is used as the input signal. And a good rule of thumb is to show a few cycles on the simulation. So 20 or 30 milliseconds will be a good number for the final time. On the other hand, you want to use a reasonably small number for the print step. Click OK and close Analysis Setup. Let's try to click the Simulate button one more time. Well, there's something going on in the simulation window, but still there's no signal. There's one more thing we need to do before calling up the signal. Get back to the schematic window. Select the DMM and put it on the right side of the input signal V3. Now check the simulation window one more time. Here's the signal. 10 milliseconds per cycle for 3 cycles. You may remove the signal after selecting it. That was the input signal. We may check the output by adding another DMM on pin number 6. Here we go, the output. We may have both the input and output on the same graph. Close this simulation. Click on the other DMM and the Simulate button. Now the graph shows both the input and output signal in different color at the same time. It's probably a little bit hard to tell there are two signals, but it does make sense because the circuit we are using is a follower, which means whatever the input signal is, the output will be on top of it. Double-click on the x-axis will allow us to change the axis settings. For example, we may choose only to show part of the signal. This shows only one cycle. Access settings may be changed in the analysis setup. Select transient. For example, we can change the final time to 10 milliseconds if we just want to show one cycle.